Hey, welcome back, all you cool cats. All right, today we're going to be doing some practice work here on an old common assessment. Well, this is probably from about 10 years ago or so. Um, what we're going to do here then is I'm just going to go through some questions and tell you what the answers were. I mean, the answers haven't changed if we have anything like this, but it should be a good learning experience for you. The difference between speed and velocity is that speed indicates the direction of the motion, and velocity does not. Well, speed indicates does not. This is actually just the vice versa. So this right here would be false. And I would fix this by saying um, velocity indicates direction. Speed doesn't. And I misspelled speed there. I'm sure I'm gonna misspell some things because I'm gonna try to go as quickly as I can. I'm sure you guys that's what you guys want. And I would say here then by definition then um, I would say speed is just how fast an object goes or is going. Graph A, all right, calculate the average speed of the object from 12 to 20 seconds. So in graph A here, 12 to 20 seconds. So what they're saying here is the slope because it's a distance time graph. So they want us to look at the slope. Well, it starts here at 200. I'm trying to find a place I can type here for you guys. So it goes from 12, 200, and then it finishes at 20, 500. So here's my ordered pairs. It didn't. There we go. So to find the slope, I'm going to simply take 500 minus 200, and then on the bottom I'm going to take 20 minus 12, and on the top we get 300. On the bottom we get 8. Well, 300 divided by 8 because this is slope. So I'm trying to make it look, 300 over 8 is going to give us an answer then of 25 meters per second. So, if you had a problem that wanted you to find the slope of something, and that's what we're asking for here, you would, show me the work. All right, that's what we did there. All right. The difference between average velocity and instantaneous velocity is the direction of the object is traveling. No, this is false. And the fix for this then is the difference between average velocity and instantaneous velocity is average velocity or instantaneous velocity is how fast. Oh, sorry. Is the difference between average velocity and instantaneous velocity is the time duration. All right. Time duration. You are looking at the velocity because the main difference here is the fact you're both cases you're looking at velocity. Instantaneous, you're looking at it at a moment. All right. Instantaneous is a moment, and average is a longer time period than instant. All right, and that's really what it comes down to. Average, you might do what's the average speed over an hour. Instantaneous is right now. How fast are you going right now? The cop doesn't pull you over because you were speeding on average for the last hour. The cop pulls you over because when he took the speed, bam, at that second, at that moment, at that instant, you were speeding. All right, calculate the acceleration from 50 seconds to 60 seconds. Well, that's here. Again, this is slope here again. So I'm going to say 50, 40. All right, so that's my first order pair I'm going to use here. 50, 40. And then my next order pair is going to be 60, 80. So now I just start, 80 minus 40 on top, 60 minus 50 on bottom. I get 40 on top, and then on bottom we get 60 minus 50 is 10. So what is this is going to be equal to, well, 40 over 10 is 4 meters per second squared. So that's my acceleration. So write down your order pairs and do your slope. Write down the two order pairs. Do y2 minus y1 over x2 minus x1. For those of you that forget that, I'll write it here. I'll type it in. Y2 minus y1 over x2 minus x1. I mean, that's our slope equation right there. All right, maybe some of you guys remember that. All right. During a collision, a seatbelt slows the speed of a crash test dummy. The direction of the net force exerted by a seatbelt is the same direction as the dummy's motion. Well, a seatbelt keeps you from going out the window or running into your dashboard. So if you're going forward, is the seatbelt exerting a force in that same direction? Well, no. It's going to be in the opposite direction. And the reason why is it's trying to keep you from going, right? A seatbelt keeps you from going out the window. But if we want to get even more detailed here, Newton's third law, for every action is an equal and opposite reaction. So if you push forward on the seatbelt's going to do what? It's going to push back. Again, that's Newton's third law. That's a lot of stuff there. I know you're not going to write all that, but I got a captive audience, so I'm going to try to get you to know as much as I can. A crane exerts a net force of 500 newtons upward on a 100-kilogram motorcycle as the crane starts to lift the car from the deck of a cargo ship. What is the acceleration of the car during this time? Well, I think it was supposed to be a car and a motorcycle. I think it's supposed to be a motorcycle in both cases. So what they're really asking us here about then is our force equation, F equals ma. So in this case, the force is 500 equals the mass of the car, which is 100, times a. Well, if you divide both sides by 100, you get a equals 5 meters per second squared. So that would be our acceleration there. So there's your equation. Put the numbers in and give your answer with units. All right, I think we're on to energy here. Evidence that energy is transferred from a golf club to a golf ball when the club strikes the ball is that the ball will immediately gain a velocity and potentially height. Well, we've talked about potential energy and kinetic energy. And kinetic energy means something has mass and velocity. Not ma. Mass and velocity. Potential energy means it has mass, gravity's pulling on it, not gravity, gravity, and it has some type of height. So, evidence that energy is transferred from a golf club to a golf ball when the club strikes the ball is that the ball will immediately. So if it has energy, it's either going to have mass and velocity, or it's going to have mass, gravity, and height, or some type of combination. They're saying it's gaining velocity, so already we know it's true because it's gaining kinetic energy. And if it's gaining potentially height, so if you hit the golf ball and it actually goes up in the air too, then it's also gaining potential energy. So this right here is all around, yay, it's true. You don't have to do anything with it except put down true in this case. But as you can tell, we talked about lots of things there. What is the kinetic energy of a 50-kilogram skydiver falling at a terminal velocity of 10 meters per second? Well, kinetic energy is equal to 1/2 mv squared. So in this case, our kinetic energy is equal to 1/2 the mass, which is 50, times the velocity squared. So 10 squared is 100. 100 times 50 is 3 zeros, 5,000. Half of that is 2,500. So our kinetic energy is equal to 2,500, and our units for kinetic energy is joules. All right. Well, hey, we're coming up on that 10-minute mark. Your job is going to be to finish this out, and hopefully I got you off to a great start here. You guys do the best you can. We'll go over some questions when you get back in class. I'll catch you on the flip side.